When you're subtracting decimals, you always want to subtract like terms. That means taking tenths from tenths, hundreds from hundreds, thousands from thousands. Let's model our terms. The flat represents 1 whole, the long represents 1/10, and the small cube represents 1/100th. Let's model our decimal. The decimal we're subtracting is 4 longs and 5 small cubes. What's the value of this decimal? If you said 45 hundredths, you would be correct. 5 hundredths are small cubes. If I cut each of my tenths into 10 hundredths, this would be 10 hundredths, 20 hundredths, 30 hundredths, 40 hundredths. I would have 45 of these small cubes if I renamed my tenths. I could model that as 0 wholes and 45 hundredths. When I subtract using pattern blocks, I'm literally going to take away. I would like to take away this time 6 hundredths. I could show that on the algorithm by saying taking away 0 ones, taking away 0 tenths, and I want to take away 6 hundredths. There's a problem. I only have 5 hundredths to take away. That means I'm going to need to rename one of my tenths in terms of hundredths. I know that 1/10 is going to be equivalent to 10 hundredths. I'll need to count out 10 of my hundredths, line them up carefully, and when I do that, 2, 4, 6, 8, 10 hundredths, I've renamed 1/10 for 10 hundredths. And now I can go ahead and take away my 6 hundredths, 2, 4, 5, and 6 hundredths. If I take them away, I'm left with 2, 4, 6, 8, 9 hundredths. The traditional algorithm would make it look like this. 4 tenths has been regrouped. I have 3 tenths remaining. I had 10 hundredths that I added to my 5 hundredths. I could say I had 15 hundredths. And 15 hundredths take away 6 hundredths leaves me with 9 hundredths. 3 tenths I'm taking nothing from. That remains 3 tenths. Don't forget your decimal to keep your place values straight. I have an answer, a difference of 39 hundredths. This would be 30 hundredths and 9 hundredths for 39 hundredths.